Okay, guys, this is the physics unit test. It's our corrections as well as the dumping opportunity for you to improve your dumping grade. Make sure in order to get full credit, you must write every single thing that we write. If we're writing it, you're writing it. Two great snipe birds are migrating. Both birds have a mass of 100 grams and are flying at 90 kilometers per hour. So they both have an equal mass of 100 grams. And they both have the same speed of 90 kilometers per hour. 90 kilometers per hour. Bird R is flying 2 kilometers above the ground, so this one is 2 kilometers above the ground. And bird Q is 2.5 kilometers above the ground. So the only difference between the two birds is that bird Q is higher than bird R. Based on the information above, which statement best describes the energy of the two birds? Well, the two types of energy we talked about are kinetic, which is energy in motion that comes from both speed or velocity and mass are the two things that affect your kinetic energy. The other type of energy is potential energy, which is stored energy due to position. Stored due to position. So those are your two types of energy. Letter A, bird Q and R have the same type of kinetic and potential. Kinetic comes from mass and velocity. They have the same mass and the same velocity, so yes, they have the same kinetic energy. But bird Q is higher than bird R, so they do not have the same potential energy. As you go up, the higher you are, means you have more potential energy. Letter B, bird Q and bird R have the same kinetic energy. We already decided that yes, they do have the same kinetic energy, but different potential energy. Yes, they do. Bird Q would have more potential energy. That looks good. Let's read the rest of them. C, bird Q and bird R have no kinetic energy. Well, they are moving and they have mass, so they have kinetic energy. That's not, we don't even need to go further. And bird Q, letter D, bird Q and bird R have the same potential, but different kinetic. No, they do not have the same potential, and they do have the same kinetic. So that's definitely not our answer. B would be the correct answer. Okay, number 2, the diagram below shows the different forces acting on a toy rocket. The total mass of the rocket is 5 kilograms. M equals 5 kilograms. Based on the information above, what is the acceleration of the rocket? Well, we have the force. We have the mass, and we're looking for the acceleration, so we would need to definitely look at our triangle, which is force equals mass times acceleration. They're asking us to find the acceleration, so we mark that out, giving us a formula of A equals F divided by M. Well, we have the M there already, so A equals F divided by 5 kilometers. We have a kilograms, that's our mass. Now the force, so over here I see 3 forces. There's a force going down, another force going down, and a force going up. Well, if 2 forces are both going in the same direction, we are going to add them together, giving us 5 newtons plus 3 newtons for a total of 8 newtons in the downward direction. And we've got 15 newtons in the up direction, so we would subtract those two since they are going opposite. 15 minus 8 is 7 newtons, giving us a total force of 7 newtons. So then the 7 newtons would go on top. So, sorry, this is 0.5. My bad. Not 5, it's 0.5. This is important, and a lot of you guys were seeing make that mistake, and I almost made it. So 0.5, so 7 divided by 0.5, we're going to get out our calculator. This gives us a total acceleration of 14 meters per second squared, and there is one answer just like that. So H would be our answer. Okay, number 3, a volcanic eruption launches 2 rocks at different masses into the air. The first rock has a mass of 10 kilograms. We'll label this one 10 kilograms. The second rock has a mass of 20 kilograms. At the eruption, both rocks accelerated at the same rate of 600 meters per second squared. So the acceleration is the same as 600 meters per second squared. Which of the following statements is true regarding the eruption of the two rocks? A, the amount of force applied to one rock was twice as much as the amount of force applied to rock 2 during the eruption. Well, if they both had the same acceleration, the one with the larger mass had to have a greater force. Because Newton's second law tells us that the amount of mass determines how much force is required to accelerate it. They both have the same acceleration, the larger one has the greater force. So this could possibly be the answer, only it's rock 2 that is the bigger one. So let's see. B, the amount of force applied to rock 1 was the same as the force applied to rock 2. Definitely not. They had to have different forces in order to have the same acceleration. The amount of force applied to rock 1 was half applied to rock 2. Well, this is rock 1, this is rock 2. This one had to be half as much force to have the same acceleration, so this one looks good. The amount of force applied to the rocks is impossible to determine without knowing the inertia. No, we can find the force definitely with the mass times the acceleration, so we can actually calculate that if we want to take 600 and multiply it times 10 to get rock 1 and 600 times 20 to get rock 2. So you can do the math or you can do the logic. Either way, C is going to be your correct answer. Okay, if a car is moving on a road at 70 kilometers per hour going due north and then changes direction and starts traveling northeast staying at 70 kilometers per hour, what happened to its speed and velocity? Well, the speed is kilometers per hour. There's our speed. The speed, no change. There was no change in the speed. This problem states that the car was going 70 kilometers per hour, changed directions, and it stayed going 70 miles per hour. However, if you see here, it changes direction. We know that velocity is both speed and direction. So if you change one, then you change the velocity. We know the speed did not change, but we know the direction did. So the velocity definitely changed. The velocity changed because the direction changed. So let's check it out. Letter F. The speed of the car changes. No, it did not. We don't even need to read further. That's not our answer. Both the speed and the velocity changed. No, the speed did not change. That is not our answer. Neither the speed nor the velocity changes. Nope, because the velocity changed since the direction changed. And letter J, the velocity of the car changes, but the speed stays the same. And number 5, a 55 kilogram student, this is going to be his mass, was riding a skateboard to school. He traveled 200 meters in 40 seconds. 200 meters would be his distance, 40 seconds would be his time. What was the average speed in meters per second? We can look on our formula chart and see that speed is equal to distance divided by time. We are given a distance of 200 meters divided by a time of 40 seconds. We plug that into our calculator. We get a total speed of 5 meters per second squared. So as it turns out, this mass was simply a distractor that you did not need in order to answer the question. Okay, number 6, the mountain climber stops at a ledge halfway up a cliff wall. The climber sets up a small gas stove and begins to cook soup in a small metal bowl. Which of the following would most increase kinetic energy of the bowl? What we need to know to answer this question is that kinetic energy is energy in motion. And it comes from two things. It comes from the mass and it comes from the speed of an object. So holding it over the edge of a cliff, that's simply going to suspend it. It's not going to increase the mass or the speed, so that will not increase its kinetic energy. Dropping it off a ledge, dropping it will definitely increase the speed as it falls. It's going to go from 0 when it's resting to moving, so it's increasing its speed, which will increase its kinetic energy, carrying it to the top of the mountain. That will actually increase its potential energy because it's making it high, raising it higher, so that's not our best answer. And bending it into a new shape, that is just changing the shape. It has nothing to do with its kinetic energy, so G is our best answer. Okay, number 7. The graph below shows the position of a moving object from 0 to 5 seconds. According to the information on the graph, which of the following statements is true for the moving object? The moving object is accelerating. In order to accelerate, that means it's changing its speed. And so if we took each of these points from 0 to 1, it only traveled about 1 meter. So 1 and 1, then the speed at that point in time would be 1 meter per second. From the for the first second to the second point right there, it looks like we traveled to about 8, which would be 9 meters. So 9 divided by 1 would be 9 meters per second. Then we go to 3, it looks like it traveled from about 9 to about 14, which is about 5 meters per second. So it looks like it's changing speed every time. From the next little time period from 3 to 4, we went from about 15 to 25, which is around 10 meters per second. This is also a curved line. And if you guys will remember, we learned that a curved line on a position time graph means it's changing. So this looks like it might be the right answer, but let's double check. The moving object is traveling at a constant speed. The only way to show a constant speed on a distance time graph is a straight line. This is not a straight line, it's a curved line. So that is not our answer. The moving object is slowing down and finally stops. Well, the only way to show stopping is to have a straight line. So if the line were to do this and go straight, that's stopping. It never went straight, so it never stopped. And the distance the moving object travels is the same for each second. Well, we can look at the graph and clearly see that's not the answer, so A is our best answer. Okay, the masses of 4 vehicles and the net forces acting on them as they enter a highway are recorded below. Which vehicle has the greatest acceleration? If we could do this math by using our triangle, force equals mass times acceleration. To find the acceleration, it's force divided by mass. Here's our force right here. Here's our mass. So we take our force and divide it by the mass for each one of these. And if we plug that into our calculator, then the first one would be 3. The second one would be 375. The third one would be 2.5. And the fourth one would be 2.25. So the greatest acceleration is going to be the biggest number, which is the coupe. We could also have done this just logically because we know that the larger, they all have the same force. If they have the same force, the one with the smallest mass is going to have the greatest acceleration. So you could have solved it either way. Number 9, a high school basketball team in Dallas travels south to Austin to participate in a tournament. The trip from Dallas to Austin is about 322 kilometers. The trip requires about 3.5 hours to complete. So this is our distance, this is our time. Which of the following represents the velocity? Well, we know velocity has 2 parts. It is speed, but it is also the direction. So if it doesn't have the direction, it can't be the velocity. So we can go ahead and eliminate 2 of these answers without even doing the math. Now to figure out the math, we simply take the distance, which is 322, divided by the time, which is 3.5 hours. Plug that into the calculator. And we get 92 kilometers per hour. And we know that that is the direction, so that is going to be our best answer. All right, number 10, Riley plays a computer game where he designs roller coasters for a virtual amusement park. Each diagram below illustrates the path of the roller car to travel. Which track should Andrew choose if he wants the roller car to have the most potential energy? That comes from position. And we know that the higher an object is, the greater its potential energy. So clearly F is 20 meters up. G starts low, so that wouldn't even go anywhere. H only has a height of 8 meters. And J only has a height of 15 meters. So the only answer that is correct is F. And 11, which of the following scenarios where a ball is in motion describes balanced forces? Balanced means that they are equal and no change in motion. A ball rolling down a ramp, a ball rolling across the floor at a constant speed. Okay, constant speed, there's no change right there, so we know that 2 is definitely one of our answers.